Hey, Vlad here, devinside.com, and welcome to the fifth episode in the Scala playlist. In the previous episode, we talked about if expressions, which was a way to bend the flow of control even further. Today, we're going to talk about something completely different. The topic of today's video is type systems, and at least for now, they don't have anything to do with the flow of control. For now. What I have here is a diagram that we discussed in episode 2. So what you see is what happens to the Scala code, right? How does it compile down to ones and zeros? And if you haven't watched this video, you might want to consider watching it. But the question is, what does this have to do with type systems, and what are type systems? So a type system is a system of proof, right? And there is the system usually resides in a component called a type checker. So type checker is a tiny program, sort of like a program that can sit anywhere on this picture. For instance, remember that I explained what happens on level 0, right? We see this 1001, 0110. I said that the first half is the instruction for the processor, and the other half is data, right? So basically we see already two sort of types of data, right? So those ones and zeros, this machine code, is just data that we feed into the processor, right? But there's sort of like two types of it, right? So one is the instructions, and the other one is the data that is fed into the instruction, right? So what a type system would do is it would make sure that you don't feed these two different types of data to the processor in the wrong order, for example, right? So it will make sure it will have like sort of like two buckets, right? And in the first bucket the instruction would go into, and in the other bucket the other part of the data will go into. This whole concept survives through this whole chain of compilation, right? So even at the very top, when we have a high level language like Scala, we still have types in there. For instance, when we say val x equals 1337, there is a way to tell Scala, right, that we want x to be an integer, right? And there will be some component that will prevent us, the type checker, it will prevent us from assigning something different to x, right? So if we say x is an integer, right, we wouldn't be able to say equals hello world. The primary purpose of a type checker is error prevention, which is the only thing that we're concerned about in this video. On the other hand, types can have more benefits. The type system, or types in general, they can help with many things. For example, they can act as documentation, or they can help with resolving merge conflicts. They can assist the communication in the team, and they can also drive the design of parts of your application a little bit. But we're going to talk about that in the future, right? So today we're only concerned about error prevention. The last thing that I'm going to say before we jump into code is actually I'm going to repeat myself. So this type checker component, it can be anywhere in the stack, and it can also be nowhere, right? So what can also happen is that it can be in the runtime, right? So there is a concept of static type systems and dynamic type systems, or in fact that was actually wrong. The concept is of static type checkers and dynamic type checkers. So the question is, when does type checking happen, right? Where in this whole chain does it happen? Now in Scala it happens during the compilation time, right? So the compiler, it goes through many phases, and one of those phases is type checking, right? So this whole error prevention thing is happening during compile time. And the source code itself is sort of like a static description of a program, right? So there's nothing running, right? It's just text, right? So it's a static model of a program, right? And that's why it's called static type checking, because it happens at compile time. Now, the alternative would be dynamic type checking, which happens in the languages like, for example, JavaScript or Python. The types are still there, but there is no compiler, right? And if there's no compiler, it means that the type checker has to live somewhere else. It lives in the runtime. So something at runtime has to make sure that the types match. But the types do exist in runtime, right? The types, they always exist, right? It's just that the question is, when is the type checker running? Does it run during the compilation process, or does it run later at runtime? Type systems are being heavily researched, and there are also other suggestions, like for example there are optional type systems, right? So you have a language which is sort of dynamic, but you can also have like an external an extra application that you can run your code through, and it will check the types, right? But we're not talking about this in this video. So we're talking about Scala, right? And Scala is a statically typed language. let's go back to our regular working environment. So we have Sublime on the left and a terminal on the right, which is in the folder of our project. So we start SPT, and we do tilde run, and we see our Hello World application. The first thing that we will do is we're going to have a bunch of vals over here, right? So we're going to have val A equals something, val B equals something, val C equals something, val D equals something. And over here, we're just going to print them all out, right? So we're going to print line A, B, C, and D, all right? And so A is going to be just 1337. What's wrong with me? 1337. B is going to be true. C is going to be a character T, and D is going to be true, like that. So let's run this. All right, as expected, we see 1337, true, T, and true. As already discussed in the previous video, print line does not really care about types, right? So it can print out anything, as you can see over here. So if you want to actually invoke the type checker explicitly, the syntax would be like this, right? So over here, we're going to have a colon, right? And after this, we're going to specify the type. And Scala has a lot of pre-built types, and many languages too. And also in the future episodes, we're going to find out how to define our own types. But as of right now, so this is an integer. Sorry, this is an integer. This is a conditional, right? But in fact, in programming, the conditionals, they have a weird name. And the name is either bool or boolean, depends on the programming language. And it all comes back to George Boole, who was a mathematician a long time ago. And I believe in the year 1847, he wrote a paper or a book, I don't really remember, where he specified the whole algebra of dealing with conditionals. And later, this whole algebra was called after him, right? So it's called the Boolean algebra. So basically, conditionals are called Boolean. And in fact, I'm going to show you later how to rename booleans to something else, which is a kind of cool thing that you can do in Scala. All right. So let's continue. So a T is a character, right? And character is called just char, or people sometimes say car. I say char, right? And the last one is a sequence of characters, right? Which is true. And if you have any programming experience from any other languages, you know that a sequence of characters is just a string, right? So there's also a type called string, right? So that thing is a string. So before we continue, the things on the right, right? They're sort of like the hard-coded values, so they're like literally in code, and therefore they're also called literals, right? They're literally in code. I'm actually not sure if they're called like that because they're like literally, you know, hard-coded, but it's kind of funny way to think of it like that, right? So the way you literally specify an integer is just by saying that it's a number, right? The way you literally specify a boolean is by either saying true or false. There's no other way. Characters, they have to be surrounded with single quotes, and strings, they have to be surrounded with double quotes, okay? There are also a few other ways to specify strings, but we're not talking about this today. Another thing that I want to mention before we continue is that Scala has a thing called type inference. And I used to pronounce it wrong for many years, so it might still slip out. So I might say inference instead of inference. But anyway, I always mean inference. Most languages actually don't have that. And I know that I haven't actually said what type inference is, right? But basically in languages like for example, Java, you always have to specify the type, right? So you always have to work with the type system explicitly. But in Scala, the compiler, right, Scala can infer the types. So type inference, what it's doing is it can reconstruct the type, right? So for example, it looks over here and it knows that it's an integer, right? So somewhere internally it does this, right? And then if you don't specify the type over here, right, it assumes that you just implicitly want a to be an integer, right? Because it just recognized what is on the other side, so it reconstructed the type for you. And by the way, that thing on the right is called type ascription, and we rarely need it, but it's kind of cool that in Scala this actually compiles, right? So I'm just going to run it again, and the result is going to be the same. Okay, we will see a few examples of this, but not even in this video, where we will need to specify the type on the right side of the binding, right? But in this video, we're probably not going to. And by the way, everything in here is scopes, as we already talked about, right? Like this, but not the types, right? So you can't do this, right? And you can also, let me just run it for quick. Yeah, you can do this, and also you can't do that. Okay, so hold up, like that. Okay, so at least for now, think about types like they live sort of in their own dimension, right? So you can't sort of have them in scopes. In fact, that's actually sort of not true, because you can have type aliases, right? So before we continue, let me actually revert that. 1, 3, 3, 7, true, and this is just a character, and this is just a string, right? So what you can also do is you can say, somewhere over here, you can say type conditional, right, equals Boolean. So in fact, what we did just now is we created an alias for Booleans, right? So now over here, we can say that it's a conditional. And on the right, we can do the same thing, right? Please don't do this in production. We really don't like that. This is just for you to play around. And the reason why I mentioned it right now is that just like a second ago, I said that types sort of live in their own dimension. But as soon as you have type aliases, right, then they also somehow relate to scopes, right? So they're all of a sudden in the scope. So if I have a scope over here, right, and I want to say val e, right, I want to say conditional equals true, it's not going to work, because in this scope, conditional doesn't exist, right? So even though types sort of live in their own dimension, there is always this relation to scopes a little bit, okay? Let me reverse it back. So I'm just going to press Control Z a bunch of times. And yeah, that should be enough. I can just remove this line. There we go. All right, so since we're already talking about scopes, I have a question for you. What if you have val e, and we're going to say that it's an empty scope? Right, and let's print line it over here. Not that it matters, but let's just do that, right? So we already know how empty scopes look like when they're printed out, but what is the type of an empty scope? Now, the type of an empty scope is called unit, and it has some mathematical background. I don't actually really know why it's called unit. But I like to believe that a scope is a single unit of computation in Scala, right? But I'm really sure that this is not true. It's just that I like to think like this, right? So everything is like a scope, and the type of a scope is unit. All right, so one really tricky thing about this, a long time ago, since the beginning of Scala, there was a decision made that, first of all, unit is a type that doesn't produce any useful values, right? So you can't really use that thing. It's sort of useless, right? And the decision was made that if it's a def, right? So if E is a def, right, and you don't specify the type, right, then you also don't need to specify the equal sign, right? So this is actually going to compile, right, and do exactly the same thing. But first, please don't ever do this. And second, this is consistent, and it sort of breaks the whole pattern of everything that I explained so far, right? For example, as soon as you specify the type, all of a sudden it doesn't work anymore, right? It needs the equal sign all of a sudden, right? And by the way, this is the preferred way to do this, because if you do this, then this will also work, right? But if you don't do this, the val is not going to work. Whoops, sorry. Save, right? So it's not going to work. So the only way this works is with a def, right? Not with a val, right? Therefore, just please don't ever use this. Anytime the return type is unit, just please specify it explicitly and use an equal sign, okay? In fact, I believe in the later versions of Scala, this other syntax will not be possible anymore. Let me switch it back to val for a sec, right? So everything is the same then, okay? So the next thing that we're going to have is a type that we're not going to specify. This is the one that we talked about in the previous video. So let's just have it over here, right? And just say that it's if true. Or actually, just for fun, let's say if b, okay? because b is a Boolean, right? So if b 10, else not 10 as a string, okay? So we still can print, we can still see 10, right? And if b is false, right, then we see not 10. And by the way, before we continue, notice that if requires the scope that is passed in to be a Boolean, right? So if we say, for example, if I don't know, 12, it's just not going to compile, right? And notice that this whole time we're actually concerned with compilation. So what I did in the beginning was tilde run, but actually for the most examples, tilde compile would not be enough. So it doesn't compile right? So it doesn't even know how to translate that in ones and zeros, okay? Let's switch back to run for a sec. All right, so we're gonna have a b here, right? So again, if it's true, then we see the 10, and if it's false, we see the string, right? And again, this is happening because println doesn't really care, right? And println doesn't really care because what println wants, you know, the way that if wanted a Boolean, println wants an any. So in Scala, a type is called a type that is basically anything is called any. A cool thing for you maybe to notice over here, right, is type inference, right? So if we don't specify any, right, then the compiler was somehow capable to figure out that, you know, the type of this expression is neither an int nor is it a string. So did it jump straight to any, or maybe there was something in between, right? And we're going to discuss this in the future, but basically there is a hierarchy of types, right? So the type inferencer, it just sort of traverses, so it walks this tree of types until it can find the match. But this is a topic for another video, all right? So let's just have an any over here again, and let's have it run. Okay, the next thing that I want to say is, just to clarify, types, they exist primarily for the compiler, right? So for the type checker, right? So the primary purpose of the type checker is to make sure that the types are matching, right? So it's error prevention, right? So as soon as you start to explicitly specify the types, first of all, you sort of sometimes do an unnecessary work, and the other part is sometimes you can actually destroy the types, right? So for example, if this is an 11, right, then the type of this expression is clearly an integer, right? So what's on the right is an integer, right? But by saying that it's any, we actually destroy the type, right? So at a later point in time, right, we can't say over here, for example, right, we can't say f plus 20, right, because we said that it's an integer, right? That's actually the print line f plus 20, all right? And it's gonna say, hey, hold on, I found an integer, but I want a string. That actually shows me that this is a wrong example, because there's also a way to concatenate strings. So what we should do is, for example, let's divide by 2. Whoops, let's divide by 2. Okay, so this is what I wanted to show you. So it's gonna say that this symbol, right, that this functionality is not available for any's, right? So even though this whole thing is an integer, right, we sort of destroyed the type. So be very careful when you specify the types. In fact, we're going to talk about this much later, but in fact, it's actually a good idea to specify the least specific type. So actually, specifying any is your best choice right now, because everything that you're doing with this program does not require it to be an integer. Right? Until we specify this, the program worked just fine, right? And therefore, if it's just fine, then the type that you are specifying should be the least specific one, right? But as soon as we are using it, right, the least specific type that we actually need becomes an integer, right? So in some cases, it is actually better to leave the type checker alone, leave the type inferencer alone, right, and let it infer all the types, right? But not always, right? Not always. One of the reasons, you know, software is called engineering is because there's no clear answer to things, right? You always have to find a balance. You have to apply your engineering skills to figure out what's the best solution for your specific problem, right? In this case, it's better to specify the type, because this is an educational video and I just want to show you all of these things. One last thing, since I already talked about if expressions in the previous video, and I'm talking about the types now, I want to show you one thing. First of all, let me have an empty line over here, right? So actually, why have an empty line? Let's just not print out all the other things. So right now we're just looking at this, right? So 10 came back, and therefore 10 divided by 2 is 5, right? So let me remove that scope real quick, right? So what I'm going to show you now has nothing to do with types. It has something to do with if expressions and scopes, right? So let's say that after this whole expression is evaluated, well, we also want to add 2, right? So if we just say plus 2, what will happen is not what you expect. So in this case, the result is 6, and actually, let me have a 12 over here, right? And let me not access b. Let me do the false, like right here. Okay, so that you see the whole expression. Okay, so what is happening here is that 2 gets added to 12 first, right? So we have the 14 because we're in the false branch, right? So we are over here, and only then it gets divided by 2, right? However, this is not what we wanted, right? So if we have true, right, then it's just going to do 10 divided by 2. Okay, then it's a 5. But what we wanted was actually this, right? We wanted that in any case, you know, in every case, 2 is always added, right? So now we have 10 plus 2, which is 12, divided by 2, which is 6. And now we have 12 plus 2, which is 14, divided by 2, which is 7. Now, it might look like I'm telling you to always specify scopes. In fact, this is not what I'm telling you. I actually hate curly braces. So what I'm telling you to do in this case is to do something like this, right? So we're going to have like a temporary thing, right? And this temporary thing is going to be this, right? This scope. And now because it's one expression, we don't need the curly braces, right? So over here, what we just want to do is to say temp plus 2. This is a way better style of coding than to have, you know, a scope around temp and to inline that thing, right? And now we don't need temp, right? So I'm not telling you to always specify scopes. I'm always telling you to give names to your scopes, and therefore to boil them down to one expression, right? Because there's like almost always a way to do this, right? Boil them down to one expression and don't have those curly braces. All right, let's continue with the video. So we had an any over here, right? And we had a, let's just have true. I just prefer to see trues instead of falses, right? So we're gonna have 10 else some string, okay? We don't need that anymore, and we want to print out everything, right? Oh, we don't need the empty line. There we go. So this is where we left off before I went to this whole if expression thing. All right, so now let's play with the type system, right? So let's switch to the compilation mode. So as of right now, we only care if the program compiles or not, right? So we've already seen, right? So if the type system expects a Boolean, we can't just give it a number, right? So we can't just give it 10, okay? So it's just not going to compile. It's going to say, hey, you just told me that you want a Boolean. Why are you giving me an integer? The thing is, and we're coming back to the importance of specifying the type, right? If we leave the Boolean out, right, now all of a sudden, everything's fine again, right? Because the only way we're using b is by printing it out, and printing it out, the print line, this function, which is the topic of the next video, it doesn't care what it prints out, and therefore the whole program figured out that it doesn't care what b is, right? So b is just any. Now this is a small program, so you see the whole code at once, right? But if this program was bigger, right, it wouldn't be so obvious anymore, right? So even in here, right? So what if you just say a, right? So now b equals a, and as of right now, you see the whole program right here. But imagine that a was actually coming from far away, right? From some different file, like I explained in the end of the previous video, right? Then you would not be able to see in here what type of a is, right? And therefore, sometimes, actually more often than not, it is actually more valuable to just verify that what you're hoping a to b is actually true. A to b, Jesus, right? So basically, if this was coming from a different file, right, it's always better to, most of the time, it's better to verify your assumptions, right? To say, okay, so I'm just going to store it in a variable called b, and I'm just going to make sure that it's a Boolean, and if it's not going to be actually a Boolean, the compiler will warn me, right, at compile time. Not when the application is actually, you know, deployed and running, and you know the user will see like an, I don't know, an empty website or something, right? Because I made a mistake, right? So again, the primary purpose of a type system is to prevent errors. All right, so let me switch that back to true real quick. Okay, so composing. Next thing that we're going to talk about is what happens if we say b over here, right? And it doesn't have anything to do with the type specifically. What I want to show you is that it is possible to create a program that compiles, right, that type checks, right, but it still contains bugs, Okay, so in fact, in this case, it's not going to work because it's a val. So the first thing that's happening is that we have a warning. Value b does nothing other than call itself recursively. We're going to talk about what recursively means, but basically in this case, it means it just calls itself. Okay, and over here it says forward reference extends over definition of value b. So basically, it says that we're accessing b before we defined it. Right. Look at what's going to happen if this all of a sudden is a def. Okay, so first of all, we still have the warning, but all of a sudden it compiles. Now, this warning has been introduced only recently, right? Back in the day, we didn't used to have it, but it's not like super useful, right? It's only useful in these very simple cases. In fact, let's just have a scope around b. Okay, let's have it like that, and just have a print line over here, right? Print line, we're in b, right? In b. All of a sudden, the warning goes away and everything compiles like nothing happened. So again, I'm showing you this just to make you understand that a type system or a type checker is not a silver bullet. And in fact, the type systems they come with different levels of strength, right? So the type system in Scala is actually very strong, but it's still not bulletproof, right? So over here, we don't have a valid program. We never have, as a programmer, we never have an intention like this. Right? You might not understand what is actually going to happen, so let's just run it. Okay, so instead of tilde compile, we're just going to say tilde run. And what's going to happen is it's going to call b all the time, all the time, all the time, and this is what's known as endless loop. And the way we kill the program, by the way, is we click on the terminal, so it's in focus, and we press Control C. Right? So now it killed everything. So if I'm going to press enter, we're going to see that it's done. It actually killed SBT, right? SBT itself, because the program that we have written was running sort of inside of SBT. So it's called a parent process. So Control C just killed the parent and therefore killed the child process, right? So this was a child process. Okay, so let's start SBT again and just go into the compiler again, not into, let's not run anything, okay? And I'm just going to show you what's going to happen with lazy val. I'm not going to explain it though, but basically it's going to compile again, right? But if we're going to run it, it's going to not run endlessly. It's actually going to explode. Unfortunately, I'm not able to explain you the reason just yet because it's just going to confuse you, right? But basically, if you say run, it's just going to explode, right? It says like runtime exception. In fact, here's the thing: like I can't explain you this. Right? Well, what happened here? But I can actually explain you exceptions. And by the way, it says, see, non-zero exit code, right? So the application usually when it finishes normally, the exit code is 0, right? So remember this whole discussion about scopes. An application itself, a program itself, is a whole scope, right? So it returns some result, right? And in this case, it's just a thing for the result for the operating system, just to signal if everything was fine, which is 0, or if some error occurred, right? And then you would have some error code, and back in the day we would have like tables with error codes, and you see, okay, 1337, that means that some specific part of the system exploded, right? So what are these exceptions? So I'm not going to explain this in detail, but I'm going to show you what is going to happen. First of all, let's go back to compilation, right? So let's stop playing with b. Let's just make it a regular Boolean, right? Let's play with a for now. Okay, what is going to happen if we divide by 0, right? So in math, you can divide by 0. What comes out is not an integer, right? But all of a sudden it compiles. The type system says, hey, everything is fine. And this is what exceptions are for. At runtime, it will understand that this is not an integer, right? And all of a sudden it can't assign it to an a. Okay, but unfortunately, at compile time, it does not know that this will fail, right? Because this value, even though it sort of looks like it exists at compile time, it doesn't, right? Because as soon as we put it into a variable, right? Let's say val x, right, equals 0, and let's say that this thing is somewhere far away, right? Or maybe it's even like fetched from the database, so it actually does not exist in code, right? And we use it over here. So there is no way for the compiler to figure out that this will actually fail at runtime. That this expression will not produce an integer. There is no way to know. by the way, there's a branch of research that is trying to figure out exactly this problem, and I think it's called contracts. Yes, yeah. So there's this thing called contracts or contract-driven programming, and it has something to do with this. Something to basically there's a way to specify that, hey, this might not be an integer after all, something like that. But we're not talking about this here. Let's actually run this and see what's going to happen. Okay, we're going to have tilde run. And we see an arithmetic exception, right? Remember that thing that happened was a lazy val was a runtime exception. It was not an arithmetic exception, right? So in fact, at runtime, because it has something to do with integers, right? So it figured out that this is an arithmetic exception, and there's a way to handle exceptions, right? There's a way to catch those sort of things, right? To catch this arithmetic exception and then to handle it in a way, right? So for example, let's say that we had a website, or we just had a terminal application, right? And the user would actually specify the x, right? So the user would type something in, and then we would try to convert it into an integer, right? And then the user can type in whatever he likes, right? He can type in hello world or something, right? And then there's a way for us to manage the situation, right? To have control over the situation. So there's a way for us to catch an exception like that, and to say, okay, in this case, I'm just going to ask the user to, to type in the number again, right? Or something like that. So we are in control. We can handle this whole situation, right? But over here, we're just talking about the fact that type systems are not bulletproof, okay? Let me actually revert the whole thing. Okay, so we have a perfectly valid program now, and we're running it, okay? We're almost at the end of this video, and what we're going to do now is I'm actually going to walk you through how a type system actually works, okay? And a hint about how it actually works is going to come from vars. So let's say that we have a var g over here, right? And we're going to say that it's an integer, and we're going to specify 10, okay? And over here, let's just print g, all right? So it works the same. Actually, we use 10 over here. Let's just use 20, right? So that we see it over here, right? So over here, we can say g equals 30 all of a sudden, right? And everything is still fine. Now, you can only specify types when you bind things the first time, right? So the type's on the left. So there's no way for us to say something like this, right? Because it's already specified over here, and in fact, we can't change it, right? So g is an integer. We said that it's an integer, therefore it always has to stay an integer, right? So we can't do hello world over here. And this is a hint about how type systems actually work. So a type system is built only on two principles. Let me actually remove everything to explain this to you. So I'm just going to have comments, right? So I'm just going to have here. So the first principle is called progress, right? And I'm just going to say what progress means. Progress says that if an expression is well typed, and well typed means that it compiles, right? It either evaluates or it is already a value, right? So basically, it's either computes to a value, right? Or it is already a value, right? So it is already a literal, right? And we're going to have an example in a few seconds, okay? And the second principle is the one that I showed you as a var, and it's called preservation. It basically means that the type can't change, right? But the formal definition, the formal explanation, it goes like this. If an expression is well typed, right, and it evaluates, right? So basically, it's a combination of progress, right? And it evaluates. So we're done with it's like the second step, right? So if an expression is well typed and it evaluates, the result, so basically what it evaluates to, must remain the same. Actually, let me be more specific. The result has the same type, right? And let's have an example. So we're gonna have val name equals Vlad, right? And we're gonna do name.length. In fact, let me print out name.length first, right? So Vlad has, my name. It has four letters, right? 4 characters. Okay, but this is too fancy for us. Let's actually just do name.length, right? So name.length is an expression, right? Now the first thing that we're going to do is progress, right? So is it a value? And the answer is no, And the second thing is preservation has type int, right? So this whole expression is an integer, right? It's 4. It's the length of my name, right? So this whole expression has a type of int, right? And in fact, let me do that. Somehow I feel like it looks better. Okay. So when the program is actually running, at some point it will know that name is Vlad, right? So the next thing that's going to happen is this. Whoops. Vlad.length, right? And the same thing is going to happen, right? So that's an expression. What about progress? Whoops, that's not what I wanted. Hold up. Progress. Is it a value? Nope. Preservation. It still has type int, right? That's not going to change. Okay. What is the next thing? Well, the next thing is actually 4, right? So 4. Now 4 is a hard-coded value, right? So it's not an expression. It's actually a literal. Okay. So progress. Is it a value? Well, actually true. Preservation has type int. And this is how type systems work. Only 2 principles, but very powerful implications. Okay, so we're at the end of this video, and type systems is a gigantic topic, right? In Scala, the type system is actually very powerful. It's very strong. There are a lot of things that you can do with types. There are a lot of ways to express your intent. Even through types, and we're going to talk about all these topics in the future. But at least right now, you have some fundamental understanding of what type systems are, what a static type system is, and what a dynamic type system is, or basically what a static language is and what a dynamic language is, right? And yeah, I hope this wasn't too confusing. And yeah, see you next week, where we're going to talk about functions. Remember, I did a sneak peek in my previous video about this one about types, and the next one about functions. I hope you liked it. Let me know in the comments if you have any questions, and cheers. Take care.